Hi everybody, today we'll be doing a couple exercises like 16.71 and 16.72 and the one that comes directly after that in homework number 16, chapter 16 number 1. Before we get started, I want to give a little review in case some people aren't as up to speed as everyone else. So these problems I'm going to be going over is going to be asking you to determine if there's going to be a precipitate that forms. Now, precipitate is another way of saying if a solid forms. So let's get the bases down. We have Q. Sorry. Now, if Q is equal to the KSP value given, this means that the solution is saturated and no precipitate will form. Now, if Q is less than the KSP value, this means that the solution is unsaturated and again no precipitate will form. Now if the Q value is greater than the KSP, that means it is above the saturation point and it will precipitate. So this is what we're mostly concerned with. So if we find when we do our problem that we'll be doing a little bit, if the Q value is greater than the KSP, that means that there is a precipitate that forms. If it's any of these two right here, that means no precipitate forms, and you can answer that as no reaction. Now we'll start the problem on the next page. Exercise 16.71 states a solution containing sodium fluoride is mixed with one containing calcium nitrate to form a solution that is 0.015 molarity in an NaF and 0.01 molarity in CaNOF. So how I do this is I simply write this out first. I have NaF has a solution that equals 0.015. And the CaNO3 solution is only 0.010 molarity. Now, why I write that may seem a little confusing to you right now, but I'll tell you why, or why it's helpful in a little bit. So, start the problem out. You have to do a little bit of Chem 1 with the ions and the charge, So we have Na plus F minus for this guy right here, and for this one over here we have Ca plus 2, and we have NO3 would be minus 1. So what goes with we'd have Na go with NO3, we would have Ca go with each other. Now, looking at this, the KSP list in the back of your book, if you don't understand that this isn't the solution, you can just simply look in the back of your KSP list, and there'll be a multiple solubility product constants for certain compounds. And like I said, if you can't understand why NaNO3 would be a solution, just look through that list and just browse through all of them. If you can't find a compound that's similar to NaNO3, that means that's not the solution. However, if you look carefully, you'll find a solution that is very identical looking to this guy right here. So you have to understand that that will be the value used during this problem. So if you look in there, it says that CaF2 equals CaF2, look for it, 1.46 multiplied by 10 to the minus 10 is its KSP value. Now, the value we find, which we're denoting as Q, is going to give us a new KSP value. Now, if that value found is greater than the KSP value, we'll have precipitate form. So that's how this connects with what I just explained to you in the first slide. So, let's just start the problem now. Let's write the constant expression for this. We would get something like KSP equals CaF2. Now, we just plug in what we know. As you see up here, might have been a little confusing earlier. I've wrote up here NaF equals 0.015 and CaNO3 will equal CaNO3 will equal 0.01. So that's what we plug into these values. Ca, we have those values right there. So we plug the 0.10 into that value, NaFF. So we plug the 0.015 value into here. We get KSP equals 0.010 multiplied by 0.015 squared. Now you might be wondering, how come you don't multiply by 2 there? You don't have to, because the concentration they give you on the top of the problem is the final concentration. It's the final product, so that's exactly what you plug into this KSP value here. Alright, so with that said, why don't you just go out and calculate this out. I got a value that equaled, Q, we'll label it equaled 2.0 times 10 to the minus 6. So this value right here, this value is greater than the KSP value that was given of 1.46 times 10 to the minus 10. If you look back at the previous slide that I did, it stated that the Q value is greater, right there, greater than the KSP. That means precipitate will form. So right here, Q value is greater. So precipitate will form as CaF2. We'll do another one on the next page, and I'll show you an example of what happens when it doesn't form. Exercise 16.72 states a solution containing potassium bromide is mixed with one containing lead acetate to form a solution that is 0.013 molarity in KBr and 0.0035 molarity in PbC2H02. So, same thing as I did last time. I'm going to set things up. I'm just going to write over here that the KBr has a concentration of 0.013 and the PbC2H3O22 equals 0.035. Alrighty, so let's start this problem out. Just like last problem, you have to do a little bit of Chem 1 right here and find the charges. I'll let you guys do that all out on your own. I figured out that Pb will go with Br, and it will be PbR2. PbR2. So, let's figure that out. Let's look into our little KSP list. If you look into that, that has a KSP of approximately 4.67 times 10 to the minus 6. Alright, so now let's do this problem out with the given concentrations. Let's write the constant expression. It's always good to do that, especially if you want to get 100% on the test. So we have PB will be PB equals, oh, I apologize, right here, that's a mistake. This should be the KSP, because I'm writing the constant expression value. KSP equals PB multiplied by BR squared. Alright, now we just plug in the values. I'm going to change my color up a little bit. And we're perfect right there, so I apologize. And we have this. So, let's see what we have. We have PB, so we have, oh, I was not supposed to have it, I apologize. So we have PbC2H3O22 equals 0.035. So that goes right here. Then we have BR, 0.0013, goes with KBR, so that value goes here. So let's just plug that in. We get PB, which will equal 0.0035 multiplied by 0.013 squared. Now when you guys do this out, I got a value of roughly 4. Nope, that's not, that's the KSP. I got a value of approximately 6.0 times 10 to the minus 7. And this value was less than the KSP value of 4.67 times 10 to the minus 6. So what does that tell you? That tells you that there is no precipitate form, no solid will form. So how you would enter that in my math lab would be no reaction.